solutions. Okay, in this solution chapter it is a problematic and very easy chapter. If you remember 5 to 6 formulas, you can solve at least one question which is based on the problem, and theoretically also 2 to 3 derivations are there. If you follow that, it will be easy. Okay, in the questions we will go towards that concept. First question is asking the molality of pure water is. As you know that in this chapter, first we learn some concentration terms like molarity, molality, normality, formality, mole fraction, etc. In this, he has asked the question which is related to molality, and molality symbol is given by what? That is called as a small m. And he asked about the pure water. He has given the 4 options. So directly you can go for the explanation here. The answer is first one. But how it came, let's see. Molarity is equal to number of moles divided by kg of solvent. I can write here also number of moles divided by kg, which is taken in the grams. And when you substitute that number of moles, you will get the answer. Okay. But how many number of moles? What is the volume? Let's see here. Here he has written is equal to 1000 divided by 18. Why 1000 is came? Because water is always taken in 1 liter, 1000 ml. And why 18 K means H2O molecular mass. 2 into 1 plus 16 into 1 is equal to 18. If you divide 1000 by 18, your answer comes 55.5. Therefore, our answer for this question is, that is A option. Molarity of pure water. Okay. Next question. The number of moles of NaCl in 3 liters of 3m solution is. See, he told number of moles, that is small m is equal to calculation, and NaCl means sodium chloride in 3 liters. He has given the volume, and 3m means what? It is called as a concentration. So again I will read the question. The number of moles of NaCl in 3 liters of 3m solution is. Okay. Here the options given are 1, 3, 9 and 27. And again when he gives the concentration, he asks the number of moles. What is the formula? That is N is equal to C divided by V. Either you can go by that formula or you can refer this one. The answer is 9. How it came? Let's see here. 3m solution means what? 3 moles in 1 liter of solvent. 1 liter means what? That is 1000 ml. Okay. And how many moles will be present in 3 liters means I can write here. 3 moles is equal to 1 liter. Therefore, for 3 liters, how many? Do the cross multiplication. 3 3s are 9. Divided by 1 is equal to 9. Therefore, 9 moles are present. Hence, the answer for this question is C. That is 9 option. And this is related to concentration term which comes under normality. Next question. 4 liter of 0.02 m. This is given concentration. Aqueous solution of NaCl was diluted by adding 1 liter of water. Therefore, the molality of the resultant solution is. Previous first question, it was the molality of only one solution. But here he is asking the resultant solution. Resultant means what? Another one concentration, this concentration you have to mix up and form the question. Okay. So options given are 0.008, 0.012, 0.016. So how it comes? Let's see. The answer given for this one is D. We know that in practicals in labs we are doing the formula which is called as mV1 is equal to m2V2, where m1 is called as molarity of first solution, V1 is called as volume of first solution, m2 is called as molarity of second solution, V2 is called as volume of second solution. And in this, what are the data given? You have to substitute in that. Okay, m1 V1 is equal to m2 V2. He has given m1 is equal to 0.02, and we told 4 liters, that is V1 is equal to, we have to calculate m2, and volume he has told after adding 1 liter. 1 liter means what? It becomes 5. Just calculate that M2 is equal to, how to do that? That is multiply this by this 0.08 divided by 5. Using the calculator or logbook, if you calculate, the answer comes that is 0.016. So again I am telling you, individual solution means use the formula m is equal to n by v. If we use the resultant, then use the formula m1 v1 is equal to m2 v2. Okay, the answer is 0.016, B option. Next question. Low concentration of oxygen in the blood and tissues of the people living at high altitude is due to. So you know that in Henry's law in solutions, the people who are climbing the mountains or the people who are diving in the sea will be suffering from the lacking of oxygen. Therefore, they use the helium and nitrogen mixed gas in the oxygen cylinders. Now the question is related to that. In the body, the concentration of the oxygen and tissues, people living at high altitude, means in the mountain. What is the reason for that? Either low temperature, low atmospheric pressure, high atmospheric pressure, and the last option is both low temperature and high atmospheric pressure. As you know, as we climb the mountain, that time what happens? Higher the altitude, higher is the temperature, lower is the atmospheric pressure. Therefore, there is a lack of oxygen, and in the blood they form the swelling. Hence, due to the low atmospheric pressure, will lead to the low concentration of oxygen in the blood. Okay. Considering the formation, breaking and strength of hydrogen bond, predict which of the following mixtures will show a positive deviation from Rolle's law. See, when you come towards the classification of ideal and non-ideal solution, we define that the solutions which obey Rolle's law at all concentration are called as ideal solution, which do not obey are called as a non-ideal solution. And we are having some condition, delta H, delta G and delta V. Okay. Related to that, he is asking breaking and strength of the hydrogen bond, which mixtures will show positive deviation. In a non-ideal solution, the positive deviation means when you mix 50 ml of the compound A with the 50 ml of compound B, there is an increase in the level of the solution. That is called as non-ideal type 1 positive deviation. He has given 4 options: methanol and acetone, chloroform and acetone, nitric acid and water, phenol and aniline. In this, which are miscible, which are non-miscible, you have to understand that. Methanol has hydrogen bonding, acetone no, chloroform no, acetone no, nitric acid yes, water yes, phenol no, aniline no, but lone pair of electrons will be there. So the correct answer for this question is, it is A. As I already told you, formation of hydrogen bond. How the hydrogen bond is formed? Let's see. CH3, that is a methyl group, O lone pair, and here the hydrogen bonding. Due to that, when it is broken and mixed with acetone, it forms the positive deviation from the Rolle's law. Hence, the answer for this question is answer A. What is the reason he has given? CH3OH and acetone on mixing, force of attraction will decrease. Okay. Next question. Which of the following aqueous solution should have the highest boiling point? Again, when you go for the different type of solution, boiling point is matter. Because of the force of attraction only, we have to think about the boiling point. He has given some of the compounds. What is the concentration first here? All are 1 molar concentration. But the compounds are different. NaOH, Na2SO4, NH4NO3 and KNO3. And you know, according to Van 't Hoff factors, the number of ions decide the boiling point. Okay. So what will be the answer? Let's see. That is the answer for this one is 0.011 Na2SO4. How it came? I will ionize that. NaOH will break as Na plus and OH minus. Na2SO4, 2Na plus SO4, 2 minus. NH4 plus and NO3 minus. K plus and NO3 minus. How many ions are there? 1 plus 1, 2, 2 plus 1, 3, 1 plus 1, 2, 1 plus 1, 2. If you see all the four options, one is having the more ions, that is 3. And take that value as a I and go for the Van 't Hoff factor. And what is that Van 't Hoff factor? All of you know, I is equal to 3. Delta dB is proportional to I. Delta dB means what? Delta means change. T means temperature, B means by boiling, or it is also called as ebullioscopic constant. If you substitute there, it goes on increasing. Hence, the answer for this question is second one compound, that is Na2SO4. Next one, the comparison, in comparison to 0.01 m solution of glucose, the depression in freezing point of 0.01 mgCl2 solution is. Again, it is related to Van 't Hoff factor. Let's see that first. 0.01 m solution, same concentration. 0.01 m solution, same concentration. But here it is glucose. Glucose will not give the ions. It is non-electrolyte. And the other compound is MgCl2. When you break it, it gives Mg2 plus and 2Cl minus ion. Again, the ions are 3. Okay. Based on this one, he is asking whether the depression in freezing point. Depression in freezing point means what? Kf, delta Tf. He is asking about this one. Same twice, about 3 times, about 6 times. If glucose has no ion means it is taken as I is equal to 1, and here 3 ions are there. When you compare 1 and 3, what is the ratio? 1 is to 3. Therefore, the answer is about 3 times, that is 1 is to 3 ratio. Okay. Next one. So you can see the answer also. It will be nearly 3 times because number of particles in this one are 3 times than glucose. Next question. An unripe mango placed in concentrated salt solution to prepare a pickle shrivels because, as you know that when we prepare the pickles, we are taking a mango and putting in the salt for few days. That time he is asking whether endosmosis takes place or exosmosis takes place. Endosmosis means what? The salt water enter inside the mango. Exosmosis means what? The liquid which is present in a mango come outside and mix with the salt solution. Okay. So 4 options he has given. It gains water due to osmosis. It loses water due to reverse osmosis. It gains water due to reverse osmosis. It loses water due to osmosis. Here 2 words you are seeing. One is osmosis, another is reverse osmosis. Osmosis means higher concentration to lower concentration. Reverse osmosis means lower concentration to higher concentration. When you compare salt and mango, who will be having a higher concentration? Salt. And mango will be having a less concentration. Therefore, whatever the liquid present in the mango will go outside. Therefore, the answer option for this one is B. It loses water due to reverse osmosis. Explanation you can see. Concentrated salt solution is a hypertonic. Hyper means what? More concentrated. Therefore, fluids inside the mango will come out and it called as shrivels. See, if it come outside, it is called as shrivels. If it goes inside, it is called as a shrinking. So this is related to application of solution. Next one. Which of the following statement is false? 4 options he has given. Let's see which one is false. 2 different solutions of sucrose of same molarity prepared in different solvent will have same depression in freezing point. What is the meaning of that? If you take 2 beakers, in that take some glucose, here also take some glucose. keep their concentration same, and you have to find the depression in the freezing point. That is called as delta Tm, whether it is false or true. Okay. The osmotic pressure of the solution is given by the equation pi is equal to CRT, whether it is correct, where C is concentration, R is equal to ideal gas, T is equal to temperature. Decreasing the order of osmotic pressure for 0.01 m aqueous solution of barium chloride, potassium chloride, acetic acid and sucrose is, concentrate here, the concentration is same. He is telling the osmotic pressure BaCl2 greater than KCl greater than CS3COH greater than sucrose. Here 4 you see 3 ions, 2 ions, 2 ions, no ions, whether it is correct increasing or decreasing order. And the next option is, according to Rolle's law, the vapor pressure exerted by volatile compound of solution is directly proportional to its mole fraction. So all the statements are lengthy. Again I will repeat from first and make you simple lines, then you can understand. What is the first option here? He told two different solutions of sucrose, same molarity. Osmotic pressure equation is pi is equal to CRT. Third one is osmotic pressure decreasing order. And fourth option is, according to Rolle's law, the vapor pressure, that is vapor pressure is exerted by volatile component. So what will be the answer proportional to mole fraction? The answer is A. False. Why means, as I already told, Tm. When I come for delta Tm, what happens here? If you take sucrose or glucose, what will be there? No ions. And when you take the solution which has no ions, it should always same depression in the freezing point. See the reason? A is false because delta Tf will depend upon the nature of solvent and their K. What do you mean by this nature of a solvent? No colligative property. And what is the definition of colligative property? Which depends upon the number but not on the solute particles. Okay. Next question. The value of Henry's constant Kh is. So all of you know how the Henry's law Kh will come, and is asking the value of Henry's constant Kh is. Okay. The value of Henry's constant Kh is. First understand what is Henry's law. The mass of the given mass of the gas is directly proportional to partial pressure. Remove the proportionality, it becomes m is equal to Kh into P. That Kh is called as a Henry's constant. Okay. Now come to the option. Greater for gases with higher solubility, greater for gases with lower solubility, constant for all gases, not related to the solubility of the gases. As I already told, Kh goes on increasing with increasing temperature. But now he is asking about the solubility. So what will be the solubility depends? See, answer is B. That is, higher the value of Kh, lower will be the solubility. Again I will explain it. Mass is directly proportional to partial pressure. Partial pressure is inversely proportional to solubility. Therefore, Kh increases, the solubility goes on decreasing. So the answer for this one is higher the value of Kh, lower will be the value of solubility. Hence, we have to go on increasing the Henry's constant. Okay, next. Consider the figure and mark the correct option. So first you see the diagram here. I think you understood it is related to reverse osmosis. Okay, this diagram is reverse osmosis. What is there in this one? I will tell you. This is the inlet. This is semi-permeable membrane. This is fresh water. This is concentrated salt solution. And here also one inlet is there. Here I am using one piston A to apply external pressure. Here also I am applying external pressure with piston B. okay, and its size is 8 picometer. Now he is asking whether the solvent flow from this side to this side or this side to this side. See the options. Water will move from side A to side B, side A to side B if pressure is lower than the osmotic pressure. Either first one. Water will move from side B to side A if pressure is greater than osmotic pressure. Either from that side will come. Third option. Water will move from side B to side A if pressure is equal. Water will move from side A to side B if pressure is equal. Okay. So again I will tell the option with the diagram here only. First option, from A to B with high pressure. Second option, B to A with high pressure. Third option, A to B with equal pressure. B to A with equal pressure. As you know that in osmosis it goes from A to B, and in reverse osmosis it comes from B to A. Therefore the answer for this question will be from B to A when it will be having the high pressure from B to A. Okay. Next question. We have three aqueous solution of NaCl labeled as A, B and C with concentration 0.1, 0.01 and 0.001. The value of Van 't Hoff factor for this C is, okay. So C, again I will tell you by the diagram here what will be taking place. Okay, see, we are having three beakers, 1, 2 and 3. This is A, this is B and this is C. What are the values he has given? 0.1 m, 0.01 m, 0.001 m. Okay, all are NaCl. Now you should tell Van 't Hoff factor of all are less than, all are greater than, all are equal, all are variable. We know that the number of ions increases, Van 't Hoff factor increases. But if the concentration goes on increase or decrease, it will not affect the Van 't Hoff factor because it does not depend on the concentration. Hence the answer for this question is IA is equal to IB is equal to IC. Okay. Now we move towards the last question, which is related to a solution containing 10 gram per dm³ of urea, where molecular mass is given, is isotonic with 5% of non-volatile solute. Mb of the solute is. Whenever you see the alphabet capital Mb, it is called as a molar mass. He has given some values and he has given the options. How to calculate and what are the explanations? Let's see. Okay, I will solve this for you. 1 by 60. What is this 1 by 60? Mass divided by molecular mass of urea is equal to 5 divided by x. What is that 5? 5 gram of non-volatile solute. X, that is molar mass of the solute. Okay, and when you calculate here, that time it is taken in terms of this one. X is equal to 300, and that becomes the molar mass of answer is 300 gram, and that contains 1% complex. Okay, these were the few questions related to solution chapter. Now we will continue the remaining questions in the next session. That is, the chapter is called as aldehydes, ketones and carboxylic acids. Thank you.